So how do you get a table file suitable for uploading into the time series tool such that you can take advantage of its capability to pull images? I'm going to show you how to do that. First, we need to go to the catalog search tool, and then within the WISE, NeoWISE universe of things, we need to find a data delivery that includes individual exposures. So all WISE has individual exposures, but I'm going to go for NeoWISE because that has a lot of individual exposures. Now, I'm going to put in my target here. Now, I personally can never, ever remember exactly which field from the database this tool needs to find the images. And there's like 3 of them, and they're fairly obscure names. I can never remember. So the only way that I know for sure that I'm going to get the fields that it needs is if I click on the long form table selection and then just select everything. It's going to give me a gazillion columns, but I kind of don't care because I'm not going to be looking at the individual columns, but the tool is going to use those individual columns. All right, run query. Okay, it found 282 epochs. It looks like there might be some wandering, so I'm going to just filter out those outliers from the jump here. Then I'm going to save this to my downloads folder. Okay, now we're going to go back to the IRSA homepage. We're going to go to the WISE mission page, scroll down, find the time series tool. Then we're going to go find the file that I just saved. I'm going to make sure it has WISE selected. And then we're going to go down, upload. So it's got the table. It's understood MJD and W1M Pro. It's got all the images. That's the light curve. Now I want to find the period for this. I'm going to go to Period Finder. Here is where we're going to have to use a little bit of voodoo. Time series analysis is a little bit of math, and honestly, it feels sometimes like a little bit of magic. There's a lot of literature you can get into on time series analysis, and it has only deepened in the era of looking for exoplanets. This movie is way too short to get into all of this, so I'm just going to invoke an argument by authority and tell you that I have been doing time series analysis, I am not kidding, since the 80s. So I'm just going to have to tell you that Lomscargle actually works. The default parameters here work surprisingly well. So you can just leave it blank. You can get into the online help to find out exactly what those parameters are set to be. But leaving it blank works most of the time in most cases. But if I do this, you can see that's clearly not the best phased light curve. Okay, so clearly that is not quite the right answer. And part of why it's doing that is because it's, if we go back here, really long time baseline and some pretty large gaps. Those large gaps do really strange things to the math, the Fourier transform math. And so it's trying to calculate over a really long time baseline. So this is a situation in which the default parameters aren't really doing a really good job. So let's redo this and just change the maximum period to 1 day and redo it. That peak is probably, that peak's probably the right answer. So we can check it. We're going to accept that. Go back over here. And remember, we've got 2 different band passes. We can ask it to phase up the W2 data for that same period. Looks pretty good, actually. So that's the process of how you get a light curve out of the catalog search tool in the right format to ingest into the time series tool with the right parameters so that you can get the image extractions with bonus help on how to make the period finder work for you. Don't forget, of course, that there is online help with specific information about the time series tool. And there is copious documentation online in general about how time series analysis works, what Lomscargle is and does, and the ins and outs of the voodoo of working with time series analysis.